Welcome to doassignment-ca. Here is the problem. A 20-pound block slides down a 30-degree inclined plane with an initial velocity of 2 feet per second. Determine the velocity of the block after 3 seconds if the coefficient of kinetic friction between the block and the plane is μk equals 0.25. Now, let us work through the solution step by step. Let's start with the free body diagram. The block sits on a 30-degree incline. We set the positive x-axis pointing down the slope and the positive y-axis pointing away from the surface. The weight acts straight down, which we resolve into a component along the slope and one perpendicular to it. The normal force pushes the block away from the surface, and kinetic friction acts up the slope because the block is sliding downward. Here is the given information. The block weighs 20 pounds, the incline is 30 degrees, the initial velocity down the slope is 2 feet per second, and we want the velocity after 3 seconds. The coefficient of kinetic friction is 0.25. The mass is the weight divided by g, giving about 0.621 slugs. We will use the impulse momentum principle along the slope direction. Since there is no acceleration perpendicular to the slope, the normal force equals the perpendicular component of the weight. That gives us n equals 20 times cosine 30 degrees, which is 17.32 pounds. The kinetic friction force is μk times n, so 0.25 times 17.32, giving 4.330 pounds acting up the slope. The net force along the slope is the weight component pointing down the slope minus the friction force pointing up the slope. That is 10 minus 4.330, which equals 5.672 pounds. The net impulse is this net force multiplied by the time interval of 3 seconds, giving 17.1 pound-seconds. Now we apply the impulse momentum principle. The initial momentum is mass times the initial velocity, which is 0.6211 times 2, giving 1.2422 pound-seconds. Adding the net impulse of 17.01 gives 18.252 pound-seconds on the left side. This equals mass times the final velocity, so we divide both sides by 0.6211 to find the final velocity. Dividing 18.252 by 0.6211 gives the final velocity of approximately 29.4 feet per second directed down the incline. We can verify this using Newton's second law. The net force divided by mass gives an acceleration of about 9.13 feet per second squared. Using the kinematic equation, v equals 2 plus 9.13 times 3, which is 29.4 feet per second. The two methods agree perfectly, confirming our answer. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.